So this is the sine law worksheet. It's not hard. I would love to get excited about teaching law of sines, but the reality is it's just a formula. That's all it is. It's just a formula. And the first part is solve for the unknown each triangle, and I'll probably do two of these. Probably do that one and that one. Now, let's see here. I know that there's 180 degrees in a triangle. So this angle is 180 minus the 88, which is 92, minus the 35, which I believe is 57. That seems right. 57 degrees. I'm just checking myself. Yeah, I'm okay with that. All right, so now I'm in a position where I could solve it. Focus on relationships that are given. By the way, the law of sine says the sine of some angle is to its opposite side as the sine of another angle is to its opposite side. So here I'm going to have the sine of 88 degrees is to 44 millimeters as the sine of 57 degrees is to x because they're opposite. And I'm going to do my cross multiplication. X sines of 88 degrees is equal to 44 sines of 57 degrees. And the opposite of multiplication has always been division, so I'm going to divide both sides by the sine of 88 degrees. Now, if you happen to take me in pre-calc, I don't show all this work. A pre-calc kid shouldn't need it. We kind of just jump to that. Because if you're in pre-calc, you should be able to jump to that. So we got 44 sines of 57. She is divided by the sine of 88. Make sure your calculator's in degree mode. I think I'm missing an 8 there. And in the magic enter key, done. 36.92 degrees. Oh, no, not degrees, millimeters. That's the side length. So it's not hard. Now, C is going to be a little harder than B because C is talking about an angle. And here's my pair that's given. The sine of 51 degrees compares to 9.4 centimeters, as the sine of x, the unknown, compares to 6. And I do the whole cross multiplication thing. I link these two together. 6 sines of 51 degrees is equal to 9.4 sines of x. And then I divide both sides by 9.4. So that gives me that the sine of x is equal to 6 sines of 51 sitting over 9.4. Now, if I want x, I have to do the opposite of sine. I have to do the arc sine. So the measure of angle x is the arc sine of this junk. 6 sines of 51 over 9.4. We'll carry that out to the nearest hundredth. Second sine, 6 sines of 51. .74 degrees. If you hear somebody in the background talking, that's Grant Turner because he's way too loud. 29.74 degrees. The seniors are complaining about work and when they're doing things, and Grant Turner is getting very upset because people are calling him out for waiting till the last minute. Don't be a Grant. All right, what's going on here? So apparently I jumped to 2. I'm only going to do one of these. This is a find everything that's missing. A and B are pretty simple. Let's do B. You got to do some of this work, so I'm going to do B. All right, so first things first is to find angle L. We would do 180 minus 84 minus 42. 180 minus 84 is going to be 96. 96 minus 42 is going to be what, 54 degrees? Seems legit. So that goes there. And now I need two sides. That's all I need. There's my lowercase l. And here's the pair that's given. The sine of 84 degrees compares to 50 as the sine of 54 compares to L. And I do the whole cross multiplication thing. L sines of 84 is equal to 50 sines of 54. And I divide. L is going to be 50 sins of 54 divided by the sin of 84. And then I push buttons. It's not a hard thing. 50 sines 54 divided by the sin of 84 is 40.67. Now you'd be tempted to do Pythagorean theorem, but don't. Some kids think you can do Pythagorean theorem, you can't. So we're going to do this one here. This will be lowercase j. And I'm going to reuse this. It's basically the same problem. I mean, it's just knowing the setup. Sine 84 is to 50 as the sine of 42 compares to lowercase j. Same cross multiplication, same stuff. J sines of 84 degrees is equal to 50 sines of 42 degrees. And I just divide by the sine 84. So 50 sines of 42 divided by the sine of 84 degrees. And you're going to get a slightly different answer, obviously. So I'm just going to change some numbers here because the whole thing's the same except that 54 becomes a 42. And press that magic enter key, 33.64. So it's about 33.64. These were meters, by the way, weren't they? Meters and meters. And now I'm moving forward. I've done 4 of your problems for you. I think there was 12 total. And here's the last one I'm doing, which is actually 2 parts. Suppose that you are the pilot of a commercial airline. You find it necessary to detour around a group of thunder showers. See the figure. You turn at an angle of 21 degrees to your original path, so you're going from west to east. Fly for a while, turn to intercept your original path at an angle of 35 degrees, 70 kilometers from where it left. And the question is, how much farther did you have to go because of the detour? Well, you need to find these 2 sides here. That's what you have to find. You got to find those 2 sides. The first thing you have to find is this angle up here. So, off to the side, you're doing 180 minus 21, which is 159. Then you take away your 35, which is, what, 124? Seems right. You need that angle right there. You need that angle because you need an angle side pair. To use law of sines, you have to have an angle and an opposite side. So I'm going to do part A here. I know that the sine of 124 degrees must compare to 70 kilometers as, and now I'm going to solve for x, as the sine of 35 compares to x. And I don't feel like writing all this down. I'm going to do 70 sines of 35 divided by that guy. 70, hopefully that makes some sense to you. I'm cross multiplying, that gives me 7 sines of 35. Now I'm going to divide by the sine of 124. 48.43. All right, I need y. It'd be a similar setup. The sine of 124 compares to 70, as the sine of 21 compares to y. It's going to be the same thing, 70 sines of 21 divided by that. You do up these about 10 times, and you kind of get the gist of what you're supposed to do. The issue is getting somebody to do this enough times. It's about 30.26. Now, this is how much further So if we take x and y, we add them together, what will we get? We'll get 118.69. How much further? We have to subtract the original distance. So that's going to be 48.69 kilometers. That's how much farther. The next thing they have here is what area is enclosed by this triangle. I haven't taught you how to do this yet, so good for you watching the video. That's part of today's lesson. It is. Part B, we're going to use this formula. That area is 1/2 AB sines of angle C. And C is what I call the trapped angle. So any two sides that trap an angle, and you can pick any angle. You could be this one, or this one. It doesn't really matter. I'm going to use 21 degrees for no good reason. Here's 70. Let me show you what I'm thinking. There's 70. The angle's 21 degrees, and we found side X to be 48.43. Where did I get 118? Why did I get 118 there? I wonder what I was thinking. 78.69. I wonder what I was thinking. Funny how my brain works like that. Sorry, just noticed I did something wrong. Take away the 70, 8.69 kilometers. Don't know where I came up with that number. Don't have a clue. Anyways, back on what I was doing. This is 48.43. So A and B can be these two side lengths, and this is my angle C. So if I'm doing this one, 1/2 of 48.43 times 70 times the sine of 21 degrees. And then it's a push buttons and a calculator. A lot of these problems are. If I had time, I'd make things up where we get to use some perfect trig ratios. But I don't. There you go. 607.45 square kilometers, 607.45. And that is square kilometers because it's an area concept. And there is your law of sines homework. Next up, I do the law of cosines.